Today we're going to look at factoring. We're going to go over 3 different ways you can factor, and then tomorrow we'll review the factoring just so you feel more comfortable with it. Let's do multiplying a binomial problem first. This is what we did yesterday. So can you multiply 2x plus 3 times x minus 5? Yesterday we looked at 2 different methods using a rectangle and also foiling. So I'm going to use a rectangle for this one. So we have 2 terms, 2x plus 3, and we have 2 terms that we put on the side, x minus 5. Where we have the plus and minus, we'll draw our lines and we'll find the area of each box. 2x times x is 2x squared. 3 times x is 3x. 2x times negative 5 is negative 10x. And 3 times negative 5 is negative 15. Let's combine like terms and write it out. So we have 2x squared minus 7x minus 15. All right, so we're multiplying out binomial. You can use FOIL or the rectangle. Today we're going to kind of do the opposite. 2x plus 3 and x minus 5 are factors of this, 2x squared minus 7x minus 15, because they multiply to it. So factors are things that multiply to a certain number. So factors of 12, 1 and 12, 2 and 6, 3 and 8, sorry, not 3 and 8, 3 and 4. You could also do the negatives, negative 1, negative 12, and so on. What are some factors of 4x squared? We could say 4 and x squared. We could say 2x and 2x. We could say 2 and 2x squared. And also the negatives of those would be factors as well. So factors are things that multiply to a number. And so today we are going to look for factors of things. And there's 3 ways we're going to look at how to do it. The first step is to pull out the GFC, or greatest common factor. What is the biggest number we can divide each term by? So the first example, we have 2x and 4. What's the biggest number you can divide each term by? And that would be a 2. So let's pull out the 2 and divide each of these terms by 2. 2x divided by 2 is just x. 4 divided by 2 is 2. So here are the 2 factors of 2x minus 4. You can check your answer by multiplying it out, and it should multiply to what you started with. Let's try the next thing. We have 3x squared, 6x, and 9. What could we pull out of all 3 terms? And that would be a 3. If we do that, we pull out the 3 and we divide each term by 3. So we'll get x squared minus 2x plus 3. These 2 are factors of what we started with. To check your answer, you can multiply it out. Okay, let's try the next one. So we have 2x to the third minus 4x squared. So what are factors of 2 and 4? That would be 2. How about x cubed and x squared? What's the biggest amount of x's you could pull out of each? And that would be 2 of them, x squared. So now we write what's left over. What if we divide 2x cubed by 2x squared? So here's what it looks like. The 2's would cancel. You have 3 x's on top, 2 on the bottom, so there would be 1 left on the top. And let's divide 4x squared by 2x squared. We would have a 2, and then x squared divided by x squared cancels. So here's the answer. If you want to check your answer, you can multiply it out, and you should get what you started with. Let's try the next one. What can you divide 12 and 40 by? Well, I know I can divide each one of those by 4. And then this has an x cubed and an x, so I can pull at least 1 x out of each one. Now let's write what's left over by dividing. 12 divided by 4 is 3. X cubed divided by x is x squared. 40 divided by 4 is 10. And x divided by x is 1. Again, you can check your answer by distributing, but these 2 are factors of what we started with. They multiply to that. And the last thing, 5 and 50, I know I can pull a 5 out of each. This one doesn't have any x's, so I can't pull any out. So we have 5x squared divided by 5 is x squared. And 50 divided by 5 is 10. So these are factors. So there's the first way you can factor. If there's a greatest common factor, you can divide each term by that and pull it out. The second method you want to use after greatest common factor. So if greatest common factor is not possible, or you already did it and you could factor more, these are the steps that we're going to use. So I'm going to refer back to these steps right here, but I'm going to give myself a little bit more room to work. I guess I could fit it on there. So the first step, factor out greatest common factor if possible. So for number 1, there's not a number I can divide out of each, so that's done. Step 2, place the polynomials in a box and circle. So here's what it looks like. Here's a box with a circle in the middle. I'm going to put the polynomial here, x squared minus 2x minus 15. Okay, so it always looks like this. Next step, find the numbers that multiply to the product of the 2 corner boxes that add to the circle. So we want 2 numbers that multiply to the 2 corner boxes, negative 15x squared, that add to the middle circle, negative 2x. So what are things that multiply to negative 15x squared that add to negative 2x? Well, I know that, let's see, 5 and 3 multiply to 15, so 5 and 3. And I can make the 5 negative so that it adds to negative 2, and I just put the x's here. So negative 5x and 3x, they multiply to negative 15x squared, and they add to negative 2x. So I'm going to put those answers, those factors, in any order in our box. And then I'm going to get the outside of the box. So think about what we did yesterday with multiplying binomials. We're going backwards. So we want to think what multiplies to x squared, and that would be x times x. What multiplies to negative 5x? We already have an x here, so this would be a minus 5. What multiplies to 3x? We already have an x here, so this would be a 3. And then to check your answer, negative 5 times 3 is negative 15. So two factors of x squared minus 2x minus 15 are x minus 5 times x plus 3. And you can write them in either order because when you multiply, it doesn't matter what order you multiply them in. Okay, let's try the next one. I'm going to give myself more room here. So number 2, is there a greatest common factor of 3x squared, x, and negative 2? There is not. So let's put this in a box and circle and see if we can figure out the factors. So first step, put it in the diagonals of your box. We have a 3x squared. We have a negative x and a negative 2. We want two things that multiply to the first box and the last box. So it multiplies to negative 6x squared. That adds to the circle, adds to negative x, and this is a negative 1x. So what are some factors of negative 6? Well, negative 6 and 1, 6 and negative 1. But do any of those add to a negative 1? No. So let's keep trying. We have 2 and negative 3. And that adds to negative 1. So this is our answer, and we have to put the x's here. Negative 3x and 2x multiply to negative 6x squared, and they add to negative 1x. So I'm going to put those in either order in my box. Now I have to get the outside. So I want two things that multiply to 3x squared. And I know that's 3x and x. Now I have to be careful where I put the 3x because I know that 3x times a number will give me negative 3x. If I were to put the 3 over here, it would be really hard to get the 2. So the 3x goes on top the way that I set it up. And I know that 3x times negative 1 is negative 3x. And x times 2 is 2x. And to check my answer, 2 times negative 1 is negative 2. So this is 3x plus 2 times x minus 1. Here are two factors that multiply to what I started with. All right, let's try the next one. So in this case, there is a greatest common factor, and that is 2. So I'm going to rewrite this, divide everything by 2. And now when I do box and circle, I'll just do the inside. So we have in our box and circle, we have an x squared, a negative 5x, and a 6. All right, I want two things that multiply to the first and the last term. So it multiplies to 6x squared. That adds to negative 5x. And, all right, factors of 6 are 1 and 6. All right, and if I make them both negative, will they add to negative 5? No. So how about 2 and 3? If I make them both negative, they'll add to negative 5x. So that is what we're going to use. Negative 2x and negative 3x. All right, let's get the outside of the box. What multiplies to x squared? That's x and x. X times what is negative 2x? That's a negative 2. X times what is a negative 3? That's a negative 3. So I'm going to write my factors, x minus 2, x minus 3. And don't forget about this 2 that we started with, so we'll put that 2 in front. All right, so these three things are factors of 2x squared minus 10x plus 12. All right, let's try a few more. Again, I'll do a screenshot. So number 4, there's no middle term, and that's fine. So let's put this in our box. X squared, we have 0x negative 9. So we want to know what multiplies to our first box and our last box. So it multiplies to negative 9x squared. That adds to 0x. And if I think of factors of negative 9, that would be negative 3 and 3. And those would work. They add to 0, they multiply to negative 9. So let's put them with our x's, and we'll get negative 3x and 3x. And we'll get x minus 3 and x plus 3. So this is x minus 3, x plus 3. Let's actually put that here. So this is x minus 3, x plus 3. All right, the next one is x squared minus 49. So x squared minus 49, let's put that in our box. Again, there's no x term, so I'll put 0x. And this is x squared, this is negative 49. We want two things that multiply to x squared that add to multiply to negative 49x squared that add to our middle, which is 0. All right, factors of 49 could be 7 and negative 7, and they add to 0. So I'm just going to put my x, and this will be a negative 7x, 7x. What multiplies to x squared? We have x and x minus 7, x plus 7. So this, the factors of x squared minus 49 are x minus 7, x plus 7. All right, let's put that here. Let's try the last one, x squared minus 100. So I'll put it right in my box and circle here. X squared minus 100. There's a 0x in here. So it multiplies to my first two terms, negative 100x squared. That adds to 0. Well, factors of negative 100 could be negative 10 and 10. So let's put those in our box in either order. So x times x is x squared, x times negative 10 is negative 10x, x times 10 is 10x, and to check your answer, negative 10 times 10 is negative 100. So this is x plus 10, x minus 10. All right, take a look at the last three examples. What do you notice? And maybe you notice that these are all square numbers and they're being subtracted. This is a pattern, a shortcut for factoring, and we call that difference of squares. So first of all, let's review what square numbers are. A square number comes from finding the area of a square. So one square number is 1 by 1. 1 times 1 is 1. That's a square number. 2 times 2 is 4. 4 is a square number. 3 times 3 is 9. 9 is a square number. So square numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and so on. These are all square numbers. Also, x squared is a square number. Difference means subtract. So if you have difference of squares, there's the shortcut, x squared minus 25. What we can do is we can take the square root of each. So the square root of x squared is x, and the square root of 25 is positive 5 and negative 5. And if you were to multiply that out, this is what you would get. The next one is also difference of squares. So we split it up. We do an x and an x. The square root of 81 is plus 9 and negative 9. And the last one, again, you're taking the square root of each. The square root of 4x squared would be 2x. The square root of 16 would be plus 4 and minus 4. So difference of squares, if they're both square numbers, you can take the square root and do plus or minus each of the square root numbers, or the square numbers. So in your assignment, you have to identify as a greatest common factor, box and circle, or difference of squares. So I'll give you a hint for the first one. The first one, this is greatest common factor. What's the biggest thing you can pull out? The next one has to be a box and circle. There's three things. It's usually a box and circle. And the last one, you could use a box and circle, but it's difference of squares would be the easiest thing. So practice factoring. Tomorrow we'll take a second look at factoring, and hopefully you get it down by then.